This also shows an idealized output of a DSC, and you can see in this graph that you have something similar to the other graph, which is increase of heat flow to the sample in order to maintain equal temperature, an exothermic event here, and then endothermic event at a later or at a higher temperature. So there are several questions to answer here, and the first one is, where is the glass transition temperature? And this question essentially relies on you knowing that the glass transition temperature is essentially the temperature at which, if you're heating up, the temperature at which you're investing enough energy in order to enable the molecule to rotate in between atoms or rotate around a covalent bond. So, I mean, if you can imagine that you have two atoms along a chain, and these are actually Brussels sprouts because I don't really have anything else. But imagine this kind of is a long chain, and at lower temperatures this chain is rigid, and when you get to the glass transition temperature you enable those bonds to kind of rotate about one another. So what this does is it enables the polymer to have some flexibility above the glass transition temperature. So how that glass transition temperature shows up in a DSC output is right here at this little hill that essentially is a change in the heat capacity. So there's more heat that is required in order to keep the temperature of the sample and the reference equivalent. So the glass transition temperature occurs somewhere in here, and normally what you do is you kind of draw a little triangle. Actually, the software does it for you, but you draw a triangle, and the glass transition temperature is somewhere in this in the sort of the halfway point of the hypotenuse of this triangle. So in this case, the glass transition temperature, you would go straight down and approximate it somewhere around 75 degrees Celsius.